So steps are fairly straightforward. First, you will graph the boundary line for the inequality. That is the line that you will solve for in your inequality. Okay, make sure that you guys use dash lines for greater than or less than signs and solid lines for greater than or equal to or less than or equal to lines. The second step is you will test a point that is not on the boundary line. That way you can figure out which side of the boundary contains your solutions. From there, you will shade the part that contains the point that would be true for your inequality. Okay, remember, flip your inequality if you multiply or divide by a negative number. So let's get after one of these. So in number one here, we do not have any y variables. So we are going to solve this one for x. So if we were to solve for x, we could start by subtracting 3 from both sides. That's going to give me negative x is less than negative 3. Next, I'll divide by a negative 1. Make sure when we divide by a negative 1 that we flip our inequality. So this is going to give me x is less than positive 3. Okay, so that one's my solved inequality. Next, so before we test a point here, x is less than 3. Anytime we have an equation that is x equals 3, remember, that's going to give us a vertical line. And we know that this inequality is going to be a dashed line because we just have a less than symbol. So let's go ahead and graph this. So if we were to graph x equals 3, we would have a point at 3, and we will have a vertical line from there. As you can tell with my line, I made a dashed line. Wasn't super great. Take my time here. To represent my less than symbol. Next, we're going to want to test a point. So you will test a point on either side of this boundary. For this example, I'm going to test the point 0, 0 because that one's commonly the easiest. So if I'm going to test the point 0, 0, I'm going to plug in 0 for x and 0 for y. In this case, I just have x. So plugging that in, I would have x is less than 3. This is obviously a true statement, so I'm going to shade the side that contains 0, 0. So I'm going to shade the left side of the graph on that one. Okay, let's repeat the process with number 2. Number 2 contains x and y, so we know that we're going to have a linear function here. And this one is already solved for y. So we can go ahead and graph this as a line. So my starting point is going to be at negative 8. Oops, start grabbing there. So my starting point is negative 8. And my slope is going to be negative 4. So I'm going to go up 4, left 1. Okay. And then I'm going to identify, do I have a dashed or solid line? Well, in this one, I once again have a less than symbol. So I'm going to make a dashed line as well. Okay, remember when graphing your dashed lines, you still need to have arrows at the end of your line. Once again, I'm going to test a point. Like I said, you have to test a point not on the boundary line. And if 0, 0 is not on the boundary line, that is what I would typically test. Once again, for this process, we're going to plug in 0 for y and x. So I've got 0 is less than negative 4 times 0 minus 8. That's going to simplify to be 0 is less than negative 8. Obviously, this is a false statement, so I'm going to shade the side that does not contain 0, 0. So I'm going to shade the negative side of this inequality. Okay, last example for now. So in number 3, this one is not solved for x or y, but since it contains both, I want to have this in, slope-intercept form. Yet this is an inequality, so it's a little bit different. So solving for y, I would start by subtracting x from both sides. That's going to give me negative 3y less than or equal to negative x plus 6. Now, solving for y, I'm going to divide both sides by negative 3. Make sure, since I divide by a negative, that you flip your sign. That's going to give me y is greater than or equal to 1/3 x minus 2. And that's going to be my inequality. Once again, this is going to be a linear boundary line, but this time we are going to have a solid line because I have a greater than or equal to. So let's go ahead and graph this. So my starting point is going to be negative 2, and my slope is 1/3. So I'm going to rise 1 and run 3. Okay. Now I'm going to go ahead, graph my line, and this time I will have a solid graph. Once again, I'm going to test a point. 0, 0 is not on my boundary line, so I will test that value. So substituting those in, you can sub these into either your solved equation or your original. I'm going to substitute into the solved. So I've got 0 is greater than or equal to 1/3 times 0 minus 2. That's going to simplify to be 0 is greater than or equal to negative 2. Obviously, 0 is greater than negative 2, so this one is true. So I'm going to shade the side that contains 0, 0. Okay, for the rest of the lesson, we do have a second page of very similar examples, and you can tell that there are even some absolute value equations on this side as well. Okay, I am going to do number 4 since we have some time here, because this one is an absolute value. Once again, we want to solve for y. So in this case, I'm going to divide both sides by negative 1. Remember, dividing by negative 1, make sure you flip your inequality. So that's going to give me y is less than negative absolute value of x plus 7. Okay, when graphing an absolute value function, you do want to identify your vertex. In this case, I have no horizontal transformation. So my x value is 0, yet I am going to move up 7. So my vertex is 0, 7. So that's my starting point. From there, identify our slope. Our a value is negative 1, so we will head negative 1 to the right, and we will just do the opposite to the left. Since we're working with an inequality here, we are going to have to identify what kind of a line we're going to use. And at this point, we are going to use a dashed because I just have a less than symbol. So I'll make my dashed boundary line. Okay. Just like with the linear equations, I will have to test a point that does not fall on the boundary line. In this case, 0, 0 is beneath the absolute value, and I have points above. So I'm going to test 0, 0 to see if I shade beneath. Testing 0, 0, I would have 0 is less than negative absolute value of 0 plus 7. Negative absolute value of 0 is just 0, so I've got 0 is less than positive 7. Yes, that is a true statement. So once again, I'm going to shade the side that contains 0, 0. Oops, don't have to move things around here. So I'm going to shade the portion that is underneath my absolute value graph. Okay, I know I went through these examples super quickly, so please try the other two on your own and come to class with any questions, but we'll take a look at them. All right, thanks for watching.